Welcome back to Method. Hope you're doing extremely well. This is your very own mascot this side. So in this video, we are going to discuss arrange consonants and vowels. So without wasting any time, let us head to the question. So the question says that you have been given a linked list, right, which contains characters. Now we all know that the characters are A to Z, right, and some of them are vowels and others are consonant. The problem says that we have to arrange these vowels and consonants such that the linked list, it contains all the vowels first and then all the consonants. Now the challenge is that we do not have to change the specific order. That is, consonants. If consonants in the linked list are occurring in the pattern B, C, C, then they should in the arranged pattern also they should arrange like B, C, C. That is, for example, this linked list you can see they are vowels. What are the vowels? A is a vowel, E is a vowel, A is a vowel, right? And what are the consonants? B is a consonant, C is the consonant. So the answer should become A connected to another vowel E connected with A, connected with A, and then all the vowels in the same order. That is first B, then C. That is, this is connected to B, this is connected to C, and at last as null. Right? All right. So I hope that you are clear with the question. That what does the question demand from you? Now this question is really easy, so no need to take panic. But there are some edge cases we have to handle using the code also. Okay. So how will I approach? Okay, so one of the approach that strikes my mind is the brute force approach. The brute force approach says me that maintain a vector of vowels and maintain a vector of consonants, right? And start traversing the links. Suppose my temp is here. If it is a vowel, insert it in vowel. If it is a consonant, insert it in consonant. That is the linked list for vowel. That is the vector for vowel will become A E A A, and for consonant it will become BC, right? Okay, okay. Now, what I will do is I will start making a new nodes. That is, my A will become this, my E will become this, my A will become this, my A will become this, and then I will start making vector for consonants. That is B, C. Now, this approach is absolutely fine. I think this is the best approach, the brute force approach. Why? Because while traversing the linked list, you can also delete the nodes. You can also delete the nodes, so the linked list space is actually gone. And while creating a new node, it will actually carry the same space that this linked list used to have, and hence it is say space complexity as O of 1 only. But you will have to see that the you have taken extra space as vectors, right? So O of n becomes the space complexity, right? I overlooked it fact in the previous approach where I was trying to solve it that this is also O of n, right? So space complexity is actually O of n, and hence it is not an efficient approach. Our try should be to complete it with O of 1 complexity and linear time complexity, right? So let us try to do that. So what is the another approach I will use? I will say my linked list is A B E C A A, right? So A B E C A A. My linked list is create two linked lists out of these nodes only. Create two linked lists out of these nodes. How? First I will create a vowel linked list and then a consonant linked list. Right? I will keep my temp here. I'll see if temp is a vowel. Yes, temp is a vowel. So make it its head. I will go here. Temp becomes a consonant. So B will come here. Now temp becomes a vowel. So A E is my new linked list. Temp comes here. Temp is my consonant. So B C is my new linked list. After that temp is here, then temp is here. So it will become A E A A. There is no problem in understanding that, right? And after that, attach this node to this node and your work is done. You have got the linked list. Just return this as your head, right? No problem in understanding that, right? Now this approach is very simple and it is very good, but I want you to write the code for this approach and give me in the comment section, because frankly I was not able to do it. I find the code of this problem very hard because I have to deal with more lot of pointers, right? But I request you to increase my knowledge base also. Please comment down the code for this approach, right? Okay, and if your code works fine and I'm able to understand it, I will surely give you the like. Okay, now moving on to the next approach. That is my approach. I use it to solve the today's problem. That is the optimized approach, I will say. Above one is also optimized. This is also an optimized approach, right? Let us optimize two, right? What I will say is I have a linked list A. What is my linked list? A, B, E, C, A, A. Right? A, B, E, C, A, A. Now what I will do? I will say I will traverse the linked list first. So my first step says traverse. And while traversing, I will do two things. My A thing contains count the length. What is the length of the linked list? B part says count the number of consonants. Okay. And C, put your tail. Put your tail. Tail means the last node of the linked list. This node is the tail. How will I do that? So I will say my temp is actually head, right? And now while temp, what I will do, if temp is a consonant, I'll say consonant plus plus. Otherwise, length will always increase. So length plus plus. Now, if temp next, like what is this node speciality? Its next is null, right? All other next are not null. So if temp's next is equals to null, I will say tail equals to temp. And now at last to traverse ahead, I will say temp equals to temp's next. Nothing else. Temp equals to temp next. Right? So this gives me total length, consonants, and my tail is put on the right pointer, right? So my tail is actually here. Now I'll say, suppose I'll say that I have got this many consonants, right? So in what case I don't have to do any operation on my linked list? In what case I have to do any operation on my linked list? I don't have to do any operation. So the case is if consonants equals to length or consonants equals to 0. In both the cases, the linked list is already arranged. Suppose all the letters are consonants, that means no vowels. I will not have to arrange it, right? And another case is if all the letters are vowels, no consonants. Okay, the linked list is arranged also, right? In that case also. So in that case, I will say return the head as usual. Do not do any operation on it. Okay. Now the third operation says where the main task arises, right? I will keep my temp here. I'll see, is this a vowel? Yes, this is a vowel, so let it be here. Okay, my temp comes here. Is this a tail? Oh, is this a consonant? Yes, this is a consonant. So I will have to move this node here. Now, how will I do that? How will I do that? So for that, I will say I will have to use a loop. Now, how many times the loop will work? How many times the loop will work? It is very specific that the number of consonants, right? If I have number of consonants as 2, that is B and C, I will have to move both these two. So I will have to do this 2 times. So what I will say, in the third step, my temp becomes my head while consonants, and as usual to avoid the segmentation fault, I will say while consonants and temp, right? Now, if temp is a consonant, temp is a consonant, that is it is either for a e i u, it is not in a e i u. How will I do that? I will use a set also, right? The code says that. Okay, so my temp is a consonant. What I will do, I will say I will have to move this node ahead, right? So my temp is actually here, right? I will have to move this node. So I actually want the reference to this node so as to break this connection and this connection. So I will carry a previous with me, right? I will carry a previous with me. Previous equals to null right now. Right, the previous node will actually point towards the just previous node of the temp. So my previous is here, right? So my first operation will be to break these connections, right? So I will say prev next equals to temps next. What will this do? This will break off this node, right? Now, actually, my tails next will become B. My tails next will become B, right? Correct? Because I have to insert it at end. So tails next becomes temp. Okay. Now, I know the temp is actually connected. This connection is actually alive. So I will have to break this up. So how will I do that? I will say temp next equals to null. Now, if you see clearly, my tail, which was here, when B gets connected to it, my tail actually comes here. And all other nodes which have to be connected will be connected here, right? So what I will say, I will say a tail is equals to temp. Tail is equals to temp. Now if you see practically, this node has been vanished from here, has come here, and this temp is actually here. Now for the next iteration, I have created a node link, I have created a connection like this, but for the next iteration I will have to keep my temp here, right? So my temp should come here. So what I will do, I'll say temp equals to press next. I'll say temp equals to press next. Now temp becomes pref next, but one thing we have to subtract is that we have actually changed, we have actually arranged the consonant. So consonant minus minus, consonant minus minus, right? So consonant minus minus. No problem in that. No problem in that, right? Okay. Now the thing is done. If I have got a consonant, I can actually do that very easily, right? Else, in the else subpart, I will say that this is not a consonant, this is a vowel. So traverse easily. So trev is equals to temp, and temp is equals to temps next. This is simple traverse, so I don't feel like making it understand even more. Trev is equals to temp, temp equals to temp next. In this way, a normal linked list will get converted, will get arranged as we want, right? Now there are some cases which I have to specifically tell. Suppose in a sub case, my B is actually here and my temp becomes here, and there are nodes left, right? So is it possible to say that after this B, temp and tail, all the operations are actually temp is equals to tail? What I'm trying to say, that suppose my linked list is E A B, my tail is actually here, my consonant is 1, so my temp will only get subtracted when temp comes here. But do I have to arrange it? Do I have to arrange it? This is already arranged, right? Because the B is actually lying at the last and all the vowels are lying at the first. So I will add a sub clause that if temp equals to tail, that is both the pointers coincide, in that case break, that the linked list ahead is already arranged, right? Now moving on, what I will say is, suppose the linked list is C B A A. Will the code work? Will the code work, guys? Yes, the code will work, but there is some misunderstanding here. But now the answer to this node will become A C B. Previously, when we were doing things, our head was actually the same. In returning the linked list, the head was actually here only, right? The original head was also here, the new head is also here. But in this case, original head is here and the new head is here, right? So I will have to deal with the head again and again, not again and again, I will have to deal with head separately. So what I will say, before this third step, that is name it as 2b, I will say a second step, that is 2b, which will say while head and cons. While head and cons, what I will say is, my heads is now my head is currently here and I will have to arrange it here, right? My tail is actually here. So now I will say my x becomes my head. I will assign this node to x, right? Okay. And now my head becomes head next, right? My head comes here. So now I will have to deal this node to come up here, right? So I will say my tails next, as usual, my tails next will become x, my x next will become tail, and my tail becomes x. Now my x max becomes null, sorry, right? And my tail will become x. I hope the work will be done and x will be assigned here and removed from here, right? Okay. So this is the only operation I want you to tell for the head, right? Now let us move to the code. I've actually explained you all the edge cases, that is the tail and temp one. Tail equals to temp one is one of the edge cases, and second edge case is for the head. That is, the if the linked list is starting from the consonant, this will only occur if the linked list is starting from the consonant, right? In the case of vowels, the first word will remain same, right? Now let us try to solve it using the code. So moving on to the code section. So alright guys, this is the code section. So I've actually coded it down. You will actually feel it very easily. And so before Okay. So before starting it, I would like to request you to subscribe to my channel if you're new here, and please follow me on the Instagram, on the LinkedIn, and connect with me on any other special social media platforms, right? So let us try to visualize the code now. Okay. So my first operation is, if head is not null or heads next is not heads next is null or head is null. In that case, I will simply return head because that means not arranging. If the linked list contains 0 or 1 nodes, I will not have to arrange it. This is already arranged, right? Then, as I said, for keeping the for checking if it is a vowel or not, I will use a set. So I created a set of all the vowels. Now, I made a temp and head. I made a temp equals to head, and I made a tail. Constant, this is for length of the constant, this is for length of the linked list. Now, simple traversal. If st does not contain, that is a set does not contain the letter of the temp, in that case it is a consonant, so I will say consonant plus plus. Otherwise, length will always get increased. And if I have reached at the last node of the linked list, I will say tail equals to temp, and I will say temp equals to temps next. Now, if constant equals to 0 and length equals to constant, that is, if no vowels, no, if all the consonants, if all the letters are vowels or all the letters are consonant, in that case, I will simply return my head because the linked list is already arranged. Now, dealing with the case when linked list is starting with consonant and consonant needs to be sent off to the last part of the linked list. In that case, I will say while my head, that is my head is not null, and my data of the head is actually a consonant. In that case, simple. X equals to head, as I discussed, X becomes head becomes heads next, tails next becomes head, tail becomes s, and tails next, that is X next becomes null. That is simply as X next becomes null. I can also say X next becomes null. Tails next is also null because tail is equals to X because in the previous operation. And that last cons minus minus because we have actually moved one consonant away. Now, for the elements in the middle, I will say my temp becomes my head and my previous becomes my null. Now, while consonant, that is I have to do the number of operations up till consonant number of times. If tail and temp coincide at any operation, that means the linked list has been arranged fully. So I will say break. Okay. Now, for the next operation, if st dot find, that is, if my data of the temp is actually equals to a consonant, in that case, I will use the swapping operations. I will say previous equals to previous next becomes temp next to break the bond. Tails next becomes temp. Temps next becomes null. We have actually discussed, right? So this code is actually discussed there. Constant minus minus and temp becomes previous of next, right? Now, else that means I am encountering a vowel. In that case, I will do the simple traversal, and at last I will return my head after the loop finish it off, right? So this code should run fine. Let us try to compile and run it. Hope you were able to understand it, and you know where to contact me in any case of misunderstanding or if you're not able to understand any concept, right? Let us try to submit it now. And please do consider subscribing to my channel and liking the video. Now, 138 days streak. Thank you for all your love, and we'll meet tomorrow in the new video. Till then, keep coding and stay safe. Signing off. Bye.